This lecture is going to be on an introduction to acid-base. An acid is a proton donor, and a base is a proton acceptor. Each day, metabolic processes produce a huge number of hydrogen ions, also known as protons. And these hydrogen ions are highly reactive, so they must be either buffered or excreted so that the body can maintain a normal pH and so that those protons don't adversely affect protein structure and function. The concentration of these protons in blood is measured as the pH. Using the acid-base formula, you can see that carbon dioxide is an acid and its conjugate base is bicarbonate. Large quantities of carbon dioxide are produced each day from the metabolism of carbohydrates and fats. So, in addition to the excretion of hydrogen ions produced from other acids, carbon dioxide must also be excreted from the body in order to maintain that livable blood pH. Carbon dioxide is a volatile acid, meaning that it can be excreted by the lungs. Non-volatile acids, such as lactic acids and keto acids, cannot be excreted by the lungs. Instead, they have to be excreted by the kidneys. Normal blood pH is approximately 7.35 to 7.45, and this is the range that cellular metabolism functions effectively. So this is the range that cells are nice and happy. An increase in the blood pH outside of its reference interval is called alkalemia. The process that trends towards an alkalemia is called an alkalosis. So this is the process. Since alkalosis is a process, you can have an osis without an actual change in the blood pH outside of the reference interval. So you can have an osis without an emia. But if there is a change in the blood pH outside of the reference interval, so there is an emia, you must have an osis. So you must have a process that leads to that emia. Acidemia is a decrease in the blood pH outside of its reference interval, whereas the process that trends toward an acidemia is called an acidosis. So again, you can have an acidosis without an acidemia, but if there is an acidemia present, then you must have an acidosis. The three main regulators of blood pH are the kidneys, the blood buffers, and the lungs. The kidneys and the blood buffers are under metabolic control, whereas the lungs are under respiratory control. The kidneys regulate blood pH by either excreting hydrogen ions in the urine or by resorbing bicarbonate and returning it to the blood. There are several blood buffer systems within the blood that act to titrate hydrogen ions. And when I say titrate, it's just a fancy word for consuming them. The most important blood buffer is the bicarbonate buffer system, and you'll learn more about the bicarbonate buffer system in the next lecture. The lungs regulate the blood pH by exhaling carbon dioxide. And remember, carbon dioxide is an acid. The blood buffers and the lungs respond rapidly to changes in blood pH, but the kidneys might take up to 3 to 4 days to respond to the changes in the blood pH and have an effect on it. These are the tests that we use to assess a patient's acid-base status. A blood gas can evaluate both the respiratory component and the metabolic component of an acid-base status. However, biochemistry tests and urinalysis tests can only assess the metabolic component. The blood gas tests will be discussed in lectures 1B and 1C, whereas the biochemical and urinalysis tests will be discussed in lectures 2A and 2B.